Okay, so now let's talk about electron dot diagrams. Okay, I know we've gone for a little while here, but this is going to be important. This is not in the book. I hope you understand this. Okay, you've got to pay close attention here. This is not in the book. And so you need to make sure you're paying very close attention to what's happening here and ask me questions because it's not in your book. Okay, here we go. The number of dots around an atom when we represent a particular element is equal to the number of valence electrons. Okay, so we're going to show you some symbols, and in these symbols, they're going to have dots around them. Those dots are the valence electrons. Okay, and remember that as we're trying to draw these Lewis structures, that the more stable atoms are the ones that have 8 valence electrons, except for hydrogen and helium and lithium and beryllium and boron. Everything else is trying to get to 8. Okay, so keep that in mind. We're trying to get to 8 valence electrons, and there are some exceptions, like I said, hydrogen, helium, and really beryllium and lithium and boron are basically going to be able to lose a few, and they'll just have 2 valence electrons, just like helium does. And then there are some exceptions for like phosphorus and sulfur, things that will actually take more than 8. But this is the way you could draw them out, okay? You could draw the element and then put a dot around it. So here's sodium with 1 dot. Remember, sodium's in the first energy level, okay? Or sorry, well, it's in that first period, the first group or family, right? And so it's got 1 valence electron, okay? You go over 1, and then you've got magnesium, and magnesium is in the second family, and so it has 2 valence electrons. And you just kind of keep going through. And you can see that we go down to neon, and neon has here 10 valence electrons, and so we've got 4, sorry, did I say 10? 10 electrons total, but 8 valence electrons. And so you've got 4 groups of 2 electrons, okay, 4 pairs. Okay, and so they're all trying to get to 8 valence electrons, and fluorine, for instance, has 7. It wants 1 more. Oxygen has 6, it wants 2 more. Nitrogen has 5, it wants 3 more. And you can see the places where it's open, carbon has 4, and it wants 4 more. Those places where they're open, where they're not paired, that's where they want an extra pair. Okay, so this is what we're looking at when we're doing electron notation. So let's see if you can practice a couple of these. Sorry, I got a sticky clicker. All right, so oxygen. I want you to pause and practice each of these. Try and write out what the electron dot structure would look like for each of these. All right? Pause and practice. And you're back. All right, so oxygen, I would write out an O, and then I would want to write out 1 electron on each side, and then I start filling in another electron on each side until I get to 6. Why did I stop at 6? Because it's in column 16. And column 16 all have 6 valence electrons. Carbon, I would start 1 on each side, and I'd be done. Why? Because carbon is in group 14, and group 14 has 4 valence electrons. Magnesium, I would just show 2 electrons. Why? Because magnesium is in column 2, and all of column 2 has 2 valence electrons. Neon, I would just put 2 around every side because neon has 8 total valence electrons, and so surround it. Now, does it matter? For instance, if I did oxygen, I would have done it this way. Would that have been fine? Yep. If I did oxygen, it would have been this way. Would that have been fine? Yep. Okay. It's not fine to do like 3 electrons up there and then do, you know, I mean, like you can't, they've always got to be in pairs or they've got to be by themselves. So we can't ever put 3 on one side, but it doesn't really matter what side we put the 1 on. On this one, could I have done my magnesium and done 1 over here and 1 over here? Yeah, you could have done that. I like to put them together because I think that they're both filling up the s orbital together, and so I like them like that. But that's not wrong to do it that way. Okay, no, the other way. Okay, so now you've done it for elements, but guess what? We can do this for compounds as well. But in order to do this for compounds, we're going to have to follow some rules. Again, this is not in your book. So write these rules down. Make sure you have them. This is not in your book. You got it? Write these down. Here we go. Now we're going to look at how to do NF3, nitrogen trifluoride. And then we've got this CH2, which is a particular type of compound that actually has some double bonds in it. And I want you to see what it looks like with double bonds, okay? So what are the rules for writing these? Drawing Lewis structures. Rule number 1, find the number of valence electrons you have. You're going to have to add up all the valence electrons you have for each of those individual elements. You have to look at the periodic table, see what column it's in, see how many electrons it has, and then add them all up, okay? Now, then you're going to arrange the symbols. You're always going to put the least electronegative atom in the middle. Typically, it's going to be something like carbon, okay? And the remainder of the atoms are going to be around the outside. A couple things you have to remember there. Hydrogen is never in the middle, okay? Halogens are not in the middle. Okay, you need to have things that want more than one valence electron in order to be in the middle so they can share with two things. If they only want one more electron, then they're not going to be in the middle because they can only share one thing. Okay, so there's a couple things to remember there. Hydrogen is always terminal or not in the middle. Halogens are usually that way as well. Once we've made a structure, now we're going to distribute all those dots. Okay, we distribute those valence electrons. And we want to make sure that each of our different atoms satisfies the octet rule, okay? So satisfy the octet rule for all atoms, the duet rule for hydrogen. In other words, hydrogen only wants two, right? And you want to use only the valence electrons that you have. Now, if you are going around and you're trying to do this and all of a sudden you run out of electrons, then you've got to do something kind of tricky. Okay, you're going to have to start making double or triple bonds. And I'll tell you what your clue is you always take from what has got the extra, take from what's happy and give to what's sad, okay? Take from the rich and give to the poor. It's kind of like the idea. It's a Robin Hood thing, right? Take to what's happy and give to what's sad, okay? And that's going to help you to form those double and triple bonds. And I'll show you an example of that when we do that CH2O. And then we want to draw the bonds, okay? What this means is anytime I have two electrons in between two atoms, I can draw the bond. In other words, I can make a line, and that line represents two electrons, okay? Every single line that you put in between these different atoms represents two electrons. If I have double bonds, then I'm going to have two lines, right? And you're not going to do this last one. You don't need to know about polyatomic ions. That'll be saved for chemistry, okay? And then check. Make sure that all of your elements are happy. Make sure that you've got octets for everything that wants octets. Make sure that you've got 2 for all the hydrogens, okay? Make sure everything's happy and that you've used the exact number of total electrons that you started with when you had to find that first number of electrons. Let's try it and see what it looks like. Okay, so here's our Lewis structure for nitrogen trifluoride. And it's going to have those bonds in between. How did we do that? How did we come up with that structure? Let's do it step by step. If I look at nitrogen on the periodic table, it's in group 15. That means nitrogen has 5 valence electrons. If I look at fluorine on the periodic table, it's in group 17, which means it has 7 valence electrons. However, I have 3 of those, right? So that means I've got 21 valence electrons with my fluorines. And 21 plus 5 is 26. So my job is to place 26 valence electrons around this thing that I'm going to be doing, right? To do my Lewis structure. Now, what do I put in the middle? Well, I don't put fluorine in the middle. Remember, hydrogens and your halogens, that group 17, they don't go in the middle. They're terminal because they only want 1 more electron. So they're going to be on the outside edges. Nitrogen can be in the middle. So I throw nitrogen up in the middle. And then my next step is, okay, fluorines have got to go around the outside of it. Don't do this, okay? If I did that, that would mean fluorine would be in the middle. You've got to make sure that all fluorines are terminal, okay? So we put our fluorines around the outside so that they're all around the outside and nothing is in the middle for the fluorine, okay? It's just nitrogen in the middle. Then that next step says to put bonds, okay, and I hope you wrote them down, but it says to put bonds between the atoms that are present. Now, as soon as I do that, I put my bonds between the atoms that are present. How many electrons is that? That's 2, 4, 6 electrons. Every line is equal to 2 electrons. So now I've used 6 electrons, and so now I can subtract 6 valence electrons from my total, which was 26. So now I have 20 valence electrons left to place around my atom. So then I just start going around and I start placing them. 2, I always want to put them in pairs. 4, 6, 8, 10, 12, 14, 16, 18, 20. Which means now I've created 26 valence electrons around the structure. That's how many I wanted to create. Does each atom have 8? This is the thing we got to check, right? Octet rule. 2, 4, 6, 8. Fluorine's happy, it's got 8. This fluorine, 2, 4, 6, 8. It's happy, it's got 8. This one, 2, 4, 6, 8. It's happy, it's got 8. What about nitrogen? Yes, because remember that the electrons that are shared between them all. So nitrogen's got 2 plus 4 plus 6 plus 8. It's 8 as well. So all of my atoms are happy. I've used all of my electrons, and so that's how I know that I have a correct Lewis dot structure for this particular compound. That's how you do it. Okay, now you're going to need to practice this and get good at it because you need to be able to do it for a test. Okay, you need to be able to recognize correct Lewis dot structures versus incorrect ones. So if you have questions on this, you better be asking me questions in class, yeah? You might need to do some examples. Maybe you want some extra practices, and we can do those in class, but make sure you speak up, or I'm going to think you just knew it all already. All right, so I just kind of wanted to get this screen up to you. If you guys want to look at this screen, you can look at this screen later on, and I just did what's on this screen. Okay, so here we are following the rules that I just showed you, but you can definitely look at it in this written form as well. Maybe you want to pause it and zoom in or whatever. All right, but let's go to the next one. Our next one is going to be CH2O, right? Draw the Lewis structure for CH2O. Let's see if we can do that. What is that going to look like? First of all, I've got to add up all my valence electrons, right? Okay, now I want you to go ahead and see if you can at least get this one started. Pause it and practice and see how far you get. This one is going to require a double bond. So just keep that in mind. All right, ready? Pause it. And we're back. Carbon, it's got 4 valence electrons. It's in the 14th column, has 4 valence electrons. Hydrogen, it's got 1 valence electron, but there are 2 of them, so we have a total of 2 valence electrons. Oxygen, 6 valence electrons. So let's add them up. 4 and 6 is 10, and 2, we have to have a total of 12 valence electrons placed around this thing. Carbon is typically a central atom. Hydrogen's never central, right? So let's see what we can do. Carbon's in the middle. Hydrogen's never going to be in the middle. Let me put an oxygen, maybe a hydrogen, maybe another hydrogen, something like that, you think, maybe? Got 2 hydrogens and an oxygen? Could be. Might also be something like this. This would also be a possibility. Maybe you tried that. Good guessing. Maybe you could get the right answer that way, but maybe not. Maybe you tried and it didn't work. Let's try it this way. Okay, so now my job is to put bonds between everything. Start with that. I've done 2, 4, 6 electrons I've used. So I got to subtract those 6 valence electrons I've used. So now I have 6 valence electrons left to place around here. So let me start placing them. 2, 4, 6. Okay, am I happy? Am I done? It looks like I'm done, but I'm not. Why? Well, look, hydrogen's happy. They only want 2. Carbon's happy. It wants 8. 2, 4, 6, 8. But oxygen's not happy. 2, 4, 6. Oh, my goodness. Oxygen's sad. Oxygen's poor. So Robin Hood, we steal from the and give to the. Which one's rich here? Which one's happy already? Which one's already happy? My carbon's already happy. And so if I can steal from carbon, steal the extra little pair that it has, and I put that little extra pair right in the middle where they get to share it, okay? So I stole from carbon, but carbon's still getting a little bit of it, right? It's still sharing. It's not completely sad. It's actually still happy because now carbon has 2, 4, 6, 8 valence electrons, and oxygen has 2, 4, 6, 8 valence electrons. Now they're both happy. And I've used my 6 and 6. I've used my 12 valence electrons. I must have finished. I must have made a correct Lewis dot structure here. And I must be so proud of myself. I hope you're proud of yourself. Did you do it? I hope so. Now, let's look at a couple other ways that could be written. The molecule can be changed and turned in different ways, right? Remember, those bonding electrons go in first. So we place the bonding electrons there and there and there. And then we put in our extra electrons, okay, that we got. And those extra electrons are going to go there, there, and there. So now we are Done. Now, again, there's other ways of writing it. You notice now I've given you 3 different ways that you could write this, and they're all correct. The one I did, and then this one with the oxygens on the bottom, and this one with the oxygens on the top, they're the same. Because remember, in 3-dimensional space, as you're turning these things around, the oxygen could be on top, or it could be on bottom, or it could be over here on the side, or it could be on that side. Right? 3-dimensional space, it doesn't matter. You have to make sure you're starting to think about these in 3 dimensions, not just in 2 dimensions. This is the same as that, and it's the same as the other one I showed you. Okay, remember each line represents 2 electrons. So I've got 4 electrons in between here, 2 electrons and 2 electrons between those. And that takes us to this, single bonds, 1 pair of electrons shared. Okay, I want you to draw really quickly as a practice. I want you to draw the Lewis structure for all 3 of those and see what you come up with. Okay, ready? Pause it and practice. And you're back, here we go. Chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. They get to share the 1 electron that they both had in common in the middle. Okay, now they both have 8. They're happy. Oxygen has 6. 1, 2, and I'm going to do 3, 4, 5, 6. I'm just going to do it that way. 1, 2, 3, 4, 5, 6. Let's say I did it that way. Uh-oh, now this oxygen's not happy. This one is because it gets to share, but this one's not. So again, what you do is you steal from the ones that are happy, since this one is happy, and you put them in the middle, and now they can share. Now, is this symmetrical? No, but this is fine. Like I said, 3 dimensions, it doesn't matter, but you could do it like that and make it feel like a little bit more symmetrical. You could also say, you know what? I don't want to show those dots. I want to show my lines. Okay, cool. I like that. Lines are good. Lines are the same thing as dots, as long as you got 2 lines or 2 dots for every line. Nitrogen. I have 5 valence electrons for nitrogen. So I've got to have a total of 10 valence electrons because nitrogen and nitrogen, right? 2 of them. And so if I say, okay, well, I have to have 10 total valence electrons, I may put 1 bond in between, that's 2. I need to place 8 more. 1, 2, 3, 4, 5, 6, 7, 8. Neither nitrogen's happy. They both have 6. They're not so happy with each other, right? So in this case, you get to steal from each other. Since neither one is happy, they can just kind of share together. And so I'm like, okay, I will give you, and I will share my 2 in the middle. So now this nitrogen's happy, but this one's not. This one's only got 6, this one's got 8. So this nitrogen that's happy now is like, okay, I will share mine. And now they are both happy. So this is a triple bond, a double bond, and a single bond. Okay? So, learned a lot, haven't you? Lots of stuff you've learned. Let's see what you've learned, okay? Let's go through our objectives and review these. Can we differentiate between ionic, covalent, metallic bonds? Yahoo! Sure can. Okay? Our types of elements. We know that element types, ionic, metal, nonmetal. Covalent, nonmetal, nonmetal. Metallic, metal, metal. Our transfer or sharing of electrons. This one's a transfer. That's a share. That's a loose share. Okay? Structure. Crystal lattice. Really strong. It's got a lattice, and it can form crystals, but it's not as strong because of hydrogen bonding. Pretty strong crystals, right? Properties. Good conductors of electricity if they're liquid and in water, but great conductors of electricity if they're liquid or solid. Okay, this one doesn't conduct electricity but solid. These are stronger bonds. These are weaker bonds. These are typically liquids and gases, some solids as well, right? Solids, liquids, and gases. These guys are all solids except for mercury, right, which is going to be a liquid. So yeah, you know these properties now, right? And can you draw models of molecules using electron dot / Lewis structures? Yeah, pretty cool stuff. And you'll get better at that in chemistry. You're going to have probably like 3 or 4 examples on your test here. In chemistry, you'll have to do it more proficiently. So, you know, we're learning the foundations now, learn what we need now so that we will be successful both now and in the future. So study this stuff hard. Make sure you learn those Lewis structures. I know that it's tough if something is not in the book, so make sure you communicate with me. All right? That way we can help you out. I hope you had an awesome time learning about some really cool stuff today. God bless you. Have an awesome day.